Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday night math night. I am so excited to see everybody here tonight. Hi, Hope. It is good to see you. You took it on Monday. I am crossing all my fingers and all my toes. And in fact, that worked for me this week for something else. I don't believe in that, but I'm not even kidding. I literally was like telling a team of mine, like, just cross our fingers and our toes and maybe we'll put it into the universe and get what we would like. And it worked. It ended up working. So I'm going to do it again for you. Hi, Trina. It is so nice to meet you. I am so glad that you're here. I love seeing new faces. So before I get started, I will give you a little introduction about me since we do have some new faces in here. I am Amy Sink. I am one of the math specialists here at the Learning Liaisons. With Priya, she's the other one that you might see here on Wednesdays every now and then. And we both offer one-on-one tutoring in addition to the boot camps. If you're like, man, I just really need some one-on-one help, some one-on-one attention, we do both offer one-on-one tutoring. Hey, Latanya, it is good to see you from Michigan. Ooh, I have a friend that lives in Michigan. She lives in Grand Rapids. And like I said, I'm in Central Florida. I was a math coach for years, and now I am an assistant principal. But this is my passion, helping teachers. I mean, I've got a lot of passions, I really do. But one of my passions is helping teachers pass that certification exam because the world needs great teachers like you. And I hate that these tests just kind of hang us up sometimes. So without further ado, let's get to it. When I am solving problems, please let me know if you have any questions. Ask questions in the comment box. That is the way that we interact. That's the way that we help each other as educators, and that's the way I can help you. If there's something that you are not seeing that you would like to see, like you're like, man, at the end, you're like, I really wish she would have done more geometry, or I really wish she would have done more I don't know, linear functions, or I really wish you would have done more square root problems. I really don't understand square roots. Please let me know in the comment box. That's going to help me prepare some different problems for you in the coming weeks. I've got a couple of people preparing for that 5165. Hey, Joseph, it's good to see you. So before we get started, I always like to do a get to know you problem, and then we'll jump right into the problems. So a get to know you question, not a get to know you problem. You can tell I'm already ready for this math. So let me know in the comment box if you haven't already, where you're from, what test are you prepping for? I know some of you have already given me that information. And the get to know you question today is going to be, hi Loie, it's good to see you. What's the get to know you question gonna be? I remember thinking of one last week, and then I was like, that's gonna be next week's get to know you question, and now I don't even remember it. So we'll go with this one. Overalls have become like the new trend, and I feel like I wore them when I was 7. So are you an overall fan? Like, are you like, yeah, those should totally come back? Or are you like, oh, those should have stayed in the 90s? Ironically, I 99% of the time think those should have stayed in the 90s, but here I am wearing overalls today. They're not like the denim, like clippy overalls, though. I feel like they're a little stretchier, they're a little comfier, they're a little bit better. I don't know. And I will not be offended if you say those should have stayed in the 90s. That does not offend me. Nashville, Tennessee. Nice. I have never been there. I would love to go there. All right. You like them on others. I love that. They look so cute on other people and not so much on me. Hey, Ricardo, it's good to see you. West Palm Beach. I love it. You're about 3 hours south of me. And the FTCE 5 through 9, I think I'll stick with a belt. Yes, I love that response. All right. Let's get started with problem number 1. And this, I am jumping right to it, into that 5165 high school math kind of stuff. So select all of the functions below that are even. Select all of the functions below that are even. So how do we even know if a function is even or odd? Let me give you the rules. And I just accidentally unplugged my iPad. How do we know if a function is even or odd? Well, the rule is if f of x equals f of negative x, then it is even. Which means, and that's all very fancy terminology, right? So if I plug in negative x into my function and it spits out f of x exactly the same way that we've seen it, it's even. That's all we need to know right now, because we are selecting all of the functions that are even. Now, I know some of you are like, well, how do I know if it's odd? I'll get there. Yes, Trina, in the 90s, you were not cool if you didn't have one strap hooked and then one strap like just hanging loose. Yes, I love them on the kids. I love overalls on the kids. Yes. All right, so if f of x equals f of negative x, then it's even. But let's go here. If f of negative x, I'm going to reverse it, equals negative f of x, then it's odd. And I'm actually going to reverse this too, because I like the way that that's put better. If f of negative x equals f of x, then it's even. If neither of those things happen, then it's neither even nor odd. So let's take a look at this in real action, because I think some of you are like, I'm still not understanding. So what I'm going to do is plug in negative x, f of negative x, okay? So f of negative x means I'm putting negative x in for x. 3x squared plus 5x minus 8. What's going to happen when I have negative x squared? I'm going to get 3x squared because x times negative x is just positive x. So it's the same thing. What happens when I do 5 times negative x? I get negative 5x minus 8. Does that equal the exact function we had before? Is this exactly the same as this? No. And because it's not exactly the same, it is not even. Is it odd? No. Because negative f of x would be negative times all of this, which when we do negative times all of that, every sign is going to flip. So negative 1 times this, negative 1 times this, and negative 1 times this would spit out negative 3x squared minus 5x plus 8. That is not what we got, so this is a neither function. Remember, we are only trying to see if it's even. So would I have done this on my test? No, I'm just doing it so you can see what odd would be if it was odd. Okay, let's do the same thing for letter B. F of negative x is going to equal 4 over 5 minus x to the 4th, but it's going to be negative x to the 4th. What is negative x to the 4th power? It's negative x times negative x times negative x times negative x. What's a negative times a negative? A positive. What's a negative times a negative? A positive. What's a positive times a positive? A positive. So this whole problem is going to equal 4 over 5 minus x to the 4th. It's going to end up equaling exactly what we started with, which means that's even. I can already see that C is not going to be even. Why? Because 2 over negative x is not the same as 2 over x. So at that point, I would stop there and say that's not even. I can keep going, but I know that that's not even. Plus the square root of negative x, and the square root of negative x is going to spit out an imaginary number. Why? Because I can't take the square root of a negative number. Why? Because the square root represents something times itself equals that thing, and a negative times a negative isn't going to equal a negative, right? So that's not going to be even. And letter D, 3 to the negative x plus 3 to the negative x. Why negative x? Well, because there's already a negative sitting in front of it, and then I have to replace the x with a negative x. What's a negative times a negative? A positive. So I end up with 3 to the negative x plus 3 to the x. What do you notice? What do you notice? It's the same, but the commutative property took over. So this is actually an even function. So in this case, we had 2 responses that were even. Now, 2 weeks ago, I had someone specifically request transformations over the X and Y axis. So let's take a look at some transformations. Now, not everybody needs to know how to do transformations, but everybody needs to understand a coordinate grid. So this is a great problem for everybody. Triangle ABC is shown to the right. If triangle ABC was to be reflected over the x-axis, over the y-axis, what would the coordinate point of A prime be? Now, part of understanding these problems is understanding the notation. So the notation of A prime just means that we are looking for the translated point. So this is triangle A, B, C. And it's reflected over the y-axis. Well, how do we know which one's the x-axis and which one's the y-axis? Because we have it committed to memory. So when I look at this, I know that this is my x-axis and this is my y-axis. And when I graph a point, I'm always going to graph x comma y because x comes before y in the alphabet. So my x-axis is horizontal, my y-axis is vertical, Trina. So that said, I'm going to look. I don't care what points B and C are. Why do I not? Every time I do that, I look like I'm telling ghost stories because the glare from my iPad comes up on my chin. Why do I not care about points B and C? Because they only asked for A. And so because they only asked for A, I'm only going to really do the A. So if I'm reflecting it over the y-axis, this is where my mirror is, and it's going to flip. You do not have to apologize. That's why we're here. Absolutely. So if it's flipping over the y-axis, I want you to think about a reflection. When you stand in front of a mirror head on and you're looking at yourself in a mirror, is your nose right in front of your nose in the mirror? Or are you looking at yourself and your nose is way over here? No. When you look in a mirror, your nose is right in front of your nose. Your eyes are right in front of your eyes. Your mouth is right in front of your mouth because it's a reflection. So, and if you're standing in front of the mirror really, 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 really far away, are you going to look like you're standing really close in the mirror? No, you're going to be just as far away in the mirror perspective as you are in real life. Same thing with reflections in the coordinate grid. If A is 3 units away from the y-axis, it's going to be 3 units away from the y-axis as A prime. So this is going to be A prime. Now, that's all I need to know. I'm done. Problem is solved. I'm going to keep going just so you can see what the reflection would look like. B is 2 units away, so this would be B. And C is 1, 2, 3, 4, 5, 6, 7, 8, 9 units away. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be your new picture. Now, what is A prime? It's going to be positive, positive because we are in the first quadrant. I'm going to go positive X, positive Y because I went right and I went up. So I went right 3, up 6. I have to get to the elevator before I can get on the elevator to get to my point. So my point is 3, 6. All right, let's look at another example of translations. triangle ABC is shown to the right. If triangle ABC is reflected over the x-axis, so now we are reflecting over the x-axis, which is this one. And I like to label everything for you guys just so you can see it. So now we're going to reflect over the x-axis. And then, oh boy. So here I am like, we're done. We're reflecting over the x-axis. But then it's reflected over the y-axis. So we've got two separate reflections happening. What would the coordinate point for B double prime be? You'll notice that it's a double prime because it's a two-step problem. So we reflect it over the x-axis. That would be B prime. And then we reflect it over the y-axis, and now we have B double prime. That's why, because we're doing it in two steps. So they want to know the second prime after all the reflections. So again, I'm only going to look at point B. I will reflect the entire triangle for everyone, but I'm just solving the problem as I would if it was the test. I'm going to reflect it over the x-axis. So I'm going to stay on the same line, and I'm going to go the same distance away. So it's 2 units up. I'm going to go 2 units down. So that's B prime. Then I'm reflecting over the y-axis. So it's 3 units away here. So it's going to be 3 units away here. So this is B double prime, which means it's going to be -3, -2, which is A. Now, let's reflect the whole triangle because I want you to see something. So, I reflect this triangle over the x-axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's A. And there's C. But then it says to reflect it over the y-axis. This is where things get a little tricky because people have a hard time conceptualizing how do I reflect it over the axis if it's literally sitting on the axis? Like the triangle is sitting on top of the axis. How am I going to reflect that? You do it 1 point at a time. When I reflect B from this side to this side, I'm going to reflect B to this side. I'm going to reflect A to this side. But I'm going to reflect C to this side. So what's going to end up happening is your triangles are going to end up reflecting over each other. Let me show you what that's going to look like.
I'm not sure I understand.
Well, Siri decided that she was going to help us. So B, it's 3 units away, so it's going to be 3 units away, and I'm going to do it in a bright color. 1, 2, 3. A is 2 units away, so it's going to be 2 units away over here, and I'm going to label these so I don't lose them. I'm going to label it out here, though, so it doesn't get lost in the shuffle. And then C is 1, 2, 3, 4 units away. So it's going to be 1, 2, 3, 4 units away over here. So it's going to land up here. And now I can connect my points. That's what a triangle would look like reflected on top of itself. Those are difficult. Any questions about what I've just done? I'm going to get a sip of water and I'm going to monitor the comments. Any questions about what I've just done before I move on? All right. I don't see any questions right now. If I see any questions pop up, I will absolutely come back. But we're going to go ahead and move on. Problem number 4. Ooh, this is a good one. Okay, so this was specifically requested. Oh man, if you are not new, the last couple weeks, my iPad has not disconnected at all. And usually it disconnects like every 20 minutes, if not more. But if you're new, welcome. If you're not new, we lost our lucky streak. So I have to reconnect it. I thought we were doing so well. Here it comes. Okay. And then I have to share the screen. It's a multi-step process. All right, here we go. So this was a requested problem. This was a requested concept. This was a requested concept. Probability was a requested concept. Decimals was a requested concept. Percents and decimals was a requested concept. Systems of equations was a requested concept. Would you look at that? Literally everything we are doing tonight was specifically requested in the past couple weeks. I want you to know, if you ask me to do it, I will do it. So put in the comments what you want to see. I have a question. Reflecting over the y-axis, is it represented as f of negative x? That is a complicated question so I'm going to be really honest with you. Yes, I am certified K-12. Yes, I got a 5 on my AP calculus test when I was in high school. However, conceptually, I really struggle myself with geometry and like memorizing stuff. So often I have to write it out. So let's take a look at that. If f of x equaled 3, 2, f of negative x would equal, and it just disconnected again, f of negative x would equal positive 3, negative 2. So no, that is not f of negative x. I am going to take your question and ask my like math genius of a mom, and I will get back to you. So I'm going to take a picture of that so I can ask my mom. There is a way that when we talk about reflections, we can talk about it in terms of f of x and f of negative x, but I want to make sure that I tell you right. So we will revisit this next week for sure. All right. So probability, a problem that was specifically requested, or a concept that was specifically requested. A bag contains 16 red marbles, 6 green marbles, and 5 blue marbles. How many additional green marbles must be added to the marbles already in the bag so that the probability of drawing a green marble is 1 out of 3? So this is interesting because I think a lot of us study problems that are like, what is the probability that we would pull out a red marble? But this takes it a little different. It gives us a scenario and says, what if? So here's how I'm going to approach this problem. I'm going to figure out how many marbles I have in my bag right now. So we have 16 red, 6 green, and 5 blue. I want you to remember that probability is the desired outcome over the total possible. The probability is the desired outcome out of total possible. So my desire is 1 out of a total of 3. Does that make sense? No, it doesn't make sense because we have more than 3 marbles. So what that tells me is this is a simplified fraction, which means that my total is going to have to be a multiple of 3, right? Because if my simplified version is 1 out of 3 and I'm going backwards, then I need to figure out what my total is going to be. But in order to simplify a fraction, I divide. So in order to unsimplify a fraction, what am I going to do? I'm going to multiply. You're absolutely right. So if I'm simplifying, I'm dividing. If I'm unsimplifying, I'm multiplying. And if I'm multiplying by something here, it's got to be a it's got to be a multiple of 3, right? So how many total marbles do I have right now? 16 plus 6 plus 5. Well, let's use our handy dandy calculator. 16 plus 6 plus 5 is 27. And I currently have 6 green marbles. So 6 out of 27 is my current. So I want to know how many marbles I need. I just got way too excited about that problem. I need to know how many marbles I need to have a probability of 1 out of 3. Well, if I add 1 green marble, that's going to add 1 to my total as well. So that would be 7 out of 28. That's not 1 out of 3. If I add 1 more green marble, that's 1 out of 4, because if I divide the top by 7 and the bottom by 7, I'm going to get 1 out of 4. I'm going to get 8 out of 29, and 29 is a prime number. If I add another green marble, I'm going to get 9 out of 30. And this, I'm realizing I made a small error. This should have been 6 blue marbles, which would make this 28. So this would be 29. No. I tried to do this problem in my head, and we've all know that does not work. So 6. Okay, this is how you would solve it. My goal was for this to be a 10 out of 30, but I obviously didn't do my math right. So let's sit and figure out what we would need to do. Instead of 6 there, this would need to be 7. There we go. So let's go back. 7 out of 28. 7. 16 plus 7 plus 5. Nope, that's still not going to work. I wanted it to be 10 out of 30. All right. It was a great concept. I'm going to play with this problem and come back to you later. But you know what we're going to do? Let's do this. Let's copy this so that we can actually solve a probability problem. So here's what I am going to do. I'm going to erase all of this, and I'm going to ask a probability problem, and I want you to solve it with me. So I'm going to cover up the question. We're going to write a new question with the scenario that we have. So, because I want to be able to solve a true probability problem with you. So let's say the question is, here's my bag. What is the probability that I pull out a blue marble? I'm going to do a two-step problem here. Now, I also want to know, what is the probability that I pull out a blue marble and then a green marble without, there goes my screen again, replacement. And I'm going to tell you why that's important here in a minute. So, what's the probability that I pull out a blue marble? Here's what I want you to remember. I want you to remember that probability is desire over total outcome. So if probability is desire out of total outcome, I need to put my desire. What's my desire? My desire is blue. What's my total outcome? My total outcome is how many marbles I have in my bag. So my desire is blue and my total outcome is 16 plus 6 plus 5. So 16 plus 6 plus 5 is 27. So blue is my desire. My total is 27. That's my answer for that one because I can't simplify that. But let's look at the next one. What is the probability I pull out a blue and then a green without replacement? Well, blue we already figured out. This is blue. But when I have multiple probabilities, I multiply them together. So blue, then green. Blue times green. But when I pull that blue marble out, I'm putting it in my pocket. So how many marbles do I have left in my bag? 26. How many green marbles are there? 6. Because I did not pull a green marble out of the bag. I pulled a blue marble out of the bag. So when I multiply those, I get 30 over 27 times 26, which is 702. And then I could simplify that by dividing by 2 or whatever. But that would be my probability, my combined probability. Okay? Let's go ahead and move on to decimals. On average, a strand of human hair grows about 1.25 centimeters per month. At this rate, how long would a strand of hair grow in 2.5 years if it were never cut and it grew at a constant rate? This is an interesting question. It seems pretty straightforward. So I'm going to look at my answer choices. 3.125, 3.75, 31.25, 37.5. Which two answers are unreasonable within the context of this problem? Which two answers are unreasonable in the context of this problem? A and B. I want you to think about it. If we start in January, and in January, the hair grows 1.25 centimeters. And then in February, the hair grows 1.25 centimeters. And then in March, the hair grows 1.25 centimeters. I've already hit 3 centimeters. Now, sometimes when we're under the stress of the test, we don't quite reason through problems like we might when we're at home. And that means that we might look at this problem and go, oh gosh, I don't know how to do decimals. I don't know what to do with this. I'm just going to multiply the numbers together. And when you do that, guess what you get? 3 point something. But if you can look at the problem and figure out that those answers are not realistic, then when you go through that process and you get an answer like that, you can realize, ooh, maybe I didn't do that so correctly. So let's pretend we took the number 1.25 and we multiplied it by 2.5. 5 times 5 is 25. I'm going to do this by hand because not everybody has a calculator. 10, 11, 12, 5, 6, add a 0. Well, placeholder, it's not adding a 0. 10, 5, 2, add them together. And there are 3 decimal places represented in the problem. So we have 3 decimal places represented in our answer. So if I didn't know how to do the problem, I just multiplied the answers together and this is what I got and I answered it and I moved on, then I would automatically get it wrong, right? But if I took that extra 10 seconds to really reason with the problem and figure out what answer choices don't make sense in the context of the problem, then I would automatically see, ooh, that does not make sense in the context of the problem. That's only 3 months worth of hair, not 2.5 years. Here's the problem. They gave us our unit per month, but they asked us in years. How many months in a year? So if I'm going to use multiplication, I have to do 1.25 times the number of months. How many months in 2.5 years? Year 1, year 2, year 2.5, half of a year. $12 plus 12 plus 6 is 30. So I'm going to multiply 1.25 times 30. Joseph, you are telling me this iPad, we have 2 good weeks and then it doesn't cooperate at all for us today, does it? So 0 times 5 times 2 times 1 is just 0. So I'm going to write those all the way across. Then I'm going to add my placeholder 0. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. 3, add it together, I get 3750. There's 2 placeholders, or there's 2 numbers holding a place in the decimal world in my problem. So there needs to be 2 numbers holding a decimal place in my answer, which gives me D as the correct answer. Hope said 7 greens and 4 blues. Okay, we're on to something. So I will go back to that problem and adjust it and we'll solve it next week. Thank you so much, Hope. That's super helpful. All right, let's move on to problem number 6. Yeah, that looks good. Sonia scored the following scores on her most recent quizzes in her science class. 87%, 7 correct out of 8, 0.89, and 4 correct out of 5. If Sonia is trying to figure out, there goes my iPad again. I'll just keep reading the question. If Sonia is trying to figure out which, I can't read the problem when it's trying to think because it grays out my screen. If Sonia is trying to figure out which quiz she did best on and which quiz she did the worst on by putting them in order from greatest to least, which of the following comparisons would be correct? So that basically is telling us we're looking for greatest to least. In a bunch of words, that's all it said. She's trying to figure out what she did best on, what she did worst on, greatest to least. How do I figure out greatest to least? Well, if I have a calculator, it makes this whole process much easier. I'm going to solve it with a calculator for my calculator people, and I'm going to solve it without a calculator for my no calculator people because I want to show you the difference. So, calculator people, I know, actually everybody, I know that percents, decimals, fractions, and ratios are all in a family, okay? So that means I can convert within all four. How do I convert a percent to a decimal? Move the decimal place 2 places to the left. How do I convert a decimal to a percent? Move the decimal place 2 places to the right. So I'm going to try to get all of these to be in percentage form because I think of a quiz as a percentage, like an 87%. So how do I convert this into a percentage? 0.89 is going to equal, hop, hop, 89%. Now, I'm going to type in 7 divided by 8 into my calculator. I get 0.875. When I type 4 divided by 5 in my calculator, I get 0.8. So when I hop my decimal 2 places to the right, I get 87.5%. Please do not write 875% because that is so far off because it's way greater than a value of 1. And 7 divided by 8 is less than a value of 1 because the numerator is smaller than the denominator. 4 over 5, hop, hop that decimal 2 places to the right. What do I do when I have an open space like that? What do I do when I have an open space like that? Plug in a decimal or plug in a 0. So that equals 80%. Now I can quickly see this is the highest. What is the second highest? 87%, 7/8, or 4/5? 7/8, because this is a 0.5% bigger than this. I'm going to stop there, and I'm going to look at my answer choices. I know I can get rid of A and D because they have 87% listed first. And I know that 0.89 is larger than 87%. So now it's just a matter of if 4/5 is greater or if 7/8 is greater. And we just determined that 7/8 was greater, so C is the correct answer. Now, if you do not have a calculator, you can very simply set up no calculator. You can very simply set up a long division problem. 7 divided by 8 is the same thing as 7 divided by 8. Now, can 8 go into 7? It can't. That's okay That's the goal if it's a fraction less than 1, right? So I'm going to add a decimal 0. 70 divided by 8 is 8 because 8 times 8 is 64. Now, that's not enough information to determine where this falls because this is an 89 and this is an 87. So I'm going to keep going. 0, bring it down. 8 goes into 60 7 times. 8 times 7 is 56. Still not enough information because I have an 87%. But 8 can go into 45 times, and that's how I get 87.5. And I would do the same thing with the 4/5. All right, I think we have time for one more problem because it's kind of a lengthy problem. I had somebody specifically request how to solve a system of equations and how do you know when to use elimination and when to use substitution. So there's really no correct answer for that because technically you can use elimination and substitution for any system of equations. Is there a more efficient way? Absolutely. But you can technically use elimination or substitution for both. Let's explore this one. I'm going to solve it both ways. So, substitution. Because technically, technically, this was built as a problem for or to be solved using substitution. So, 3x plus 5y equals 13. 2x plus y equals 4. If I can get a variable by itself, then I can substitute. So I immediately see I can get y by itself by just subtracting the 2x. So I'm going to subtract 2x from both sides. So I get y equals 4 minus 2x. Because y and 4 minus 2x are exactly the same, that's what that equal sign means, I can plug this in for y. So I have 3x plus 5y equals 13. Now I just solve. Distribute 3x plus 20 minus 10x equals 13. 3 minus 10 is negative 7x plus 20 equals 13. Subtract 20 from both sides. Negative 7x equals negative 7. Divide both sides by negative 7 and x equals positive 1. Now I can plug that back into either equation and find y if I needed to. In this case, I only needed to find x. But what do we know about systems of equations? All a system of equations is two equations that are running on the same coordinate grid. And so when we solve them, what we're finding is their intersection point, which is the only point that works in both equations. So by plugging x in, I can find that. Now, that's how you would use substitution for this problem. How would we do elimination? Simple. I'm going to multiply this one by negative 5. So I'm going to get the same thing on the top. Distribute. Because if I multiply the entire thing, I'm not changing anything. Negative 10x minus 5y equals negative 20. Some of these numbers are starting to look familiar, aren't they? When I add these equations together, I get negative 7x. That disappears. 5 minus 5, hence elimination. 13 minus 20 is negative 7. I prefer elimination almost every time, but that's just me. You can solve almost every problem using substitution or elimination. Next week, we're going to do a word problem with substitution and elimination. So, that was a rough session because my screen did not want to cooperate today. That said, what do you want to see next week? What do you want to see me solve next week? And I will add it to my list. I am going to turn it back over to Dr. A for some closing remarks, but I will hang out while he stays on so that I can add a list of next week. You are so welcome, Chris. Thanks for joining us. So I'm going to switch it back over to Dr. A, but let me know what you want to see me solve next week. Hope, I'm crossing all my fingers and all my toes for you. And to my new people in the room, it was so nice to see you. Geometry, matrices, high school pedagogy, distance formula, absolutely. These are all excellent suggestions. All right, y'all, I will see you actually in exactly 1 week. It's my birthday. So I will see you next week for my birthday. All right, I will see you guys later.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.